Hello, and today we're going to be doing question 11 of section 1A in linear algebra done right. So you can read the question in the textbook. Basically, we want to show that this is not possible. So how are we going to do that? Well, let's first realize that you can distribute lambda into each element of the vector. And once you've done that, then you can get an equation. Oops, I just deleted that. That's not what I wanted to do. Then you get an equation. And this is a equation in complex numbers with a constant coefficient. It's just a constant. So you can solve for lambda, and you can do that for another combination. So the first combination I did was lambda times 2 minus 3i equaling 12 minus 5i. You can also do, I recommend doing the loss one because the second one actually does hold, as you can see in this first bit. We solve it and they equal each other. But yeah, so you can, oh no. Yeah, so you can do it for any combination. So if you do the first two on either side, then you can solve for lambda, and then once you've done that, set them equal to each other because they both equal lambda, and then cross multiply across, you get this equals this, and use the multiplication in complex numbers to bring them down to a single complex number. And the first two are equal, so let's try at index 1 and 3. So now we're going to try index 1 and 3. I skipped this first step here, and once you repeat the steps, you do get that they're not equal, therefore lambda cannot exist. And that's the proof for question 11. I'll see you in the next one.